Good morning, class. In the chapter steroids, we are moving to the next part, that is the female sex hormones. So, in the last lecture, we have seen the male sex hormones, then anabolic steroids, androgenic steroids. So, they are related with the male. Now, the next part it is the female sex hormone. These are the hormones which are secreted in female. These hormones are called as the female sex hormone. So, there are two types of hormones which are present in the female. One is the progestin, that is the progesterone. Second one is the estrogen. Okay, now we will start with the first one, that is the progestin. So what is progestin? So the progestin is the class of compounds having the activity similar like progesterone or progestational activity. So the compounds which are showing the activity like progestin, such compounds comes under the progestin. So progestin सारखी activity दाखवणारे जे compounds आहेत ते सगळे compounds, they सगळे hormones, they are comes under the progestin as the female sex hormones. For example, progesterone and 19-nortestosterone. These are the two main female sex hormones as a progestin. They are present. As the name indicates, the 19-nortestosterone. This name is similar like the male sex hormone, that is the testosterone. So they exhibit the androgenic activity. But due to the removal of 19-methyl group, somewhat they shows less amount of androgenic activity and more kind of activity similar like progestin. So due to the removal of this one, they show the activity or their activity remains as the progestational only, and they show very less amount of activity of male sex hormones. Okay, so these are the two structures. You can observe the progesterone and 19-nortestosterone. So here hydrogen is present. If here CH3 is present, it becomes testosterone. So if we are removing the methyl group which is present at the 19th position, then the given drug becomes 19-nortestosterone, which having the progestational activity. And this drug is the example of a progesterone. It is the structure of the progesterone. So it is the 21 member or 21 carbon containing the female sex hormones. The main problem with the progesterone is that they consist of ketone group. Okay, and when ketone group is present, there is a chances of reduction of that ketone group, and they can undergo the hydrolysis reaction or they can undergo the fast metabolism. So progesterone undergo rapidly metabolism, and when it undergo metabolism, they are converted into compound called as 5 beta pregnane diol. So here you can observe. So here one ketone group is present, here one ketone group is present. So when we are giving a progesterone as a drug, okay, progesterone female sex body female body मध्ये तयार होत असतं, पण आपण जर एक्सटर्नली प्रोजेस्टेरॉन तयार करून ते जर फिमेलच्या बॉडीमध्ये आपण इन्सर्ट केलं तर काय होईल, they undergo the rapid metabolism by the reaction called as the reduction reaction. And when the rapid metabolism takes place, this C double bond O is converted into CHOH, and this double bond O is converted into hydroxy group. Such structure is called as 5-pregnane diol. This hydrogen is a beta position, so such drug is called as 5-beta pregnane diol. There is also chances that this progesterone can undergo the metabolism by the hydroxylation reaction at 6th position as well as the 11th position. Okay. So this is second, third, fourth, fifth. This is the 6th position. There is chances of hydroxylation of this position 9, 10, and this 11th position. So here there is a chances that is the given progesterone can be undergo the hydroxylation at 6 as well as the 11th position. Okay, we are moving to the next part, that is the SAR of progesterone. This is the important part, how the modification is the drugs can be done so that the progesterone is actually undergoing the rapid metabolism. So we have to avoid the rapid metabolism of progesterone. So how we can done? So due to the rapid metabolism of progesterone at 3, 6, 11 and 20 position. ओके. सो हा कीटोन ग्रुप थर्ड पोझिशनला आहे. इथल्या कार्बनवर हायड्रोजायलेशन होतं, ह्या कार्बनवर हायड्रोजायलेशन होतं आणि हा जो कीटोन आहे ह्या कीटोनवर हायड्रोजायलेशन होतं. सो द हायड्रोजायलेशन टेक्स प्लेस ॲट 4 पोझिशन, 3, 6, 11 and 20. So these positions the hydrogenation takes place. So it is necessary to prevent the metabolism of progesterone at this position. To avoid the metabolism of progesterone, the first part is to introduce hydroxy group at 17th position. And when we are introducing hydroxy group at 17th position, this C double bond O, it does not undergo the metabolism, that is the C20 ketone group, it does not undergo the metabolism by the hydroxylation reaction. Okay, so by introducing the hydroxylation or hydroxy group at 17th position, and this is shown by the dotted line. So you can observe here, this is shown by the dotted line, that means it is 17 alpha hydroxy group. So 17 alpha hydroxy, remaining structure is like progesterone, so it is the 17 alpha hydroxy progesterone. Okay, so this 17 alpha hydroxy progesterone can be responsible to avoid the metabolism at this ketone group, that is the 20th position ketone group. So we have added a hydroxy group at the 17th position to avoid the metabolism of progesterone at 20th position. So in that 17 alpha hydroxy progesterone, we can go for some modification so that the activity of a drug can be increases. So the activity of 17 alpha hydroxy progesterone is enhanced by the following changes or following substitution. In that first one, unsaturation at position 6 and position 7. So here you can observe the double bond is present, okay, between 6 and 7th position. So if unsaturation is done at 6 and 7th position, we can increases the activity of 17 alpha hydroxy progesterone, as well as at 17 hydroxy group we can go for the esterification so that the duration of activity will also increase, and such drug is the megestrol assisted. So please note down this structure, it is important. It is the megestrol acetate which having the unsaturation at 6 and 7 position. The second modification is that substitution of CH3 group or halogen group at 6 position. So this is CH3, or we can substitute with any halogen like chlorine, fluorine. So if substitution at 6 position can be done with the help of CH3 and halogen, the activity can be increases. And generally this is dotted lines, that is it is the alpha substitution. So alpha substitution at 6 and positions by CH3 or any halogen, it can enhances the activity. Example of drug, it is the medroxyprogesterone acetate. This is the structure of medroxyprogesterone acetate. So similar structure of megestrol acetate, they having the ester group at 17 position, alpha ester group. Here double bond is present, here only the CH3 group present instead of double bond, so it gives the structure that is the medroxyprogesterone acetate. Then third modification, if we can add methyl group at 11 position, so this is the 11 positions, we can add methyl group at 11 position, then it will enhances the activity. Next one, substitution of fluorine group at 21st position, we can enhance the activity. So here CH3 group is present at 21st position. If we can convert it into CH2F or CHF3 or CF3, so like this, if you are converted into the fluorine containing compound, it will enhances the activity. And finally, esterification of 17 alpha hydroxy group, we can increase the activity. So here you can observe esterification is done. Here also you can observe esterification is done in megestrol as well as the medroxyprogesterone. So if we are making the esterification of the 17 alpha hydroxy group, then it increases the duration of action, because when we convert it into ester, the hydroxy group असेल there is a phase 2 metabolism होणार and it can be eliminated easily from the body. But when it consists of a ester group, first it has to be hydrolyzed and then it converted into hydroxy and COH group. So ह्यासाठी वेळ जास्त लागतो. त्यामध्ये जो ड्युरेशन ऑफ ऍक्टिव्हिटी आहे किंवा ड्युरेशन ऑफ ऍक्शन आहे, ती ड्युरेशन ऑफ ऍक्शन आहे ती एनहान्स होते. So these are the 5 modifications we can enhance the activity of 17 alpha progesterone. First one, unsaturation at 6-7 position. Second one, fluorine or halogen or CH3 substitution at 6 position. Then methyl at 11, fluoro at C21, and if 17 alpha hydroxide we can convert it into the ester form so that the activity will be enhanced. Then the second part in the progesterone, first part 17 alpha hydroxy progesterone, second part in SCR is the retroprogesterone. Okay, if we invert the configuration at C9 and C10, then it will result into the retroprogesterone. So what do you mean by inversion of configuration? So generally this 19 methyl group is present in the beta form, that is it can be shown by the straight line. If it is backside of the plane, that is the alpha CH3 group, then the configuration at C10 and C11 position changes, and when the configuration changes it is called as retroprogesterone. So structure सगळं same progesterone, फक्त 19 position चा CH3 आहे. If we are showing by the dotted lines, it becomes the alpha methyl group. Then the configuration at 9 and 10, it inverts and it will result into the structure called as the retroprogesterone. Again, similar kind of modifications we can done what we have seen in the 17 alpha hydroxyprogesterone. If unsaturation can be done at C6 and C7 positions, it will increase the activity. So here we can see there is a double bond present. So this drug is called as dydrogesterone. Dydrogesterone. So dydrogesterone is a retroprogesterone which having the more activity, or it having the enhanced activity. So in this way 17 alpha hydroxyprogesterone CG modification is same modification, that is the substitution of CH3 or halogen at C6 positions, methyl group at C11 positions, substitution. So these modifications it can be also done in the retroprogesterone. So 17 alpha hydroxyला पण हे मॉडिफिकेशन करू शकतो. 19 रेट्रोप्रोजेस्टेरॉनला सुद्धा आपण सिमिलर काइंड ऑफ मॉडिफिकेशन्स आहेत ते करू शकतो. सो एसआर लिहिताना हे जे पॉइंट आहेत हेच पॉइंट तुम्हाला यामध्ये रिपीट करायचे आहेत. फक्त चेंज काय, 19 पोझिशनचा जो डॉटेड लाईन्सने दाखवलेला आहे ते 19 पोझिशनच्या डॉटेड लाईनने जे दाखवलेलं आहे, इट says it is having the inversion of configuration, that is it is a retroprogesterone. Okay, now third part, that is the 19 nor testosterone. So we have said that the progesterone having the two types of hormones or two types of drugs, that is the progesterone and second one 19 nor testosterone. So you can observe at the 19 position there is the absence of methyl group. So such kind of drug, if the 19 position methyl group is absent in testosterone, then the drug becomes 19 nor testosterone, which having the progestational activity. The first point regarding the SAR of this 19 nor testosterone is that if we are introducing the alkyl group at C17 position, then it blocks the oxidation and it will increases the activity. So here you can observe here alkynyl group is produced, that is the C triple bond CH. That is the alkynyl group. It is present at the 17 position. Generally it is the 17 alpha position. So if such position is, this group is added, so this hydroxy group or the metabolism of this hydroxy group can be reduced, or the rate of metabolism can be reduced. So it is called as norethyltestosterone or ethinyl nortestosterone. Norethiosterone or ethinyl nortestosterone is the example of drug. Similarly, another drug is there, norgestrone, where C triple bond CH alkynyl group is present. Only at 18 position there is a ethyl group is present instead of methyl group. So norgestrone is also example there for your syllabus. It is their drug. So please go through the structure. That is the introduction of alkynyl group at C17 position can be enhanced the activity by blocking the metabolism of hydroxy group. The next part B, the substitution of chlorine at C21 or addition of CH3 at C18, it will enhances the activity. ओके. सो नॉर्गेस्ट्रॉन मध्ये आपण काय केलेलं आहे, CH3 चं कन्वर्जन C2H5 मध्ये केलेलं आहे. सो इट विल एनहान्सेस द activity. Then third point, what it says, unsaturation of ring B or C, it will increases the activity. जर आपण रिंग बी आणि सी मध्ये अनसॅच्युरेशन केलं, सो इफ दिस जनरली काय असतं, इथे डबल बॉन्ड असतो. हा डबल बॉन्ड जर ह्या पोझिशनला केला, ओके. सो आय विल टेल यू हाऊ द डबल बॉन्ड प्रेझेंट. ओके, आता ही रिंग आहे, ही ए बी रिंग आहे, ह्या पुढच्या तुमच्या रिंग आहे. डबल बॉन्ड जनरली टेस्टोस्टेरॉन मध्ये येत असतो. सो हा टेस्टोस्टेरॉनचा डबल बॉन्ड काढायचा आणि हा बॉन्ड जर इथं दिला, दॅट मीन्स अनसॅच्युरेशन ऑफ रिंग ए अँड बी. हा पार्ट आहे तो ए ला पण अटॅच आहे, बी ला पण अटॅच आहे. दॅट इज द अनसॅच्युरेशन ऑफ रिंग ए अँड बी or unsaturation in the ring B and C. It will enhances the activity. So the example is norethanol. So that is the example, norethanol. So you can observe double bond is present at this position. So this drug is called as norethanol. The next part, if introduction of methyl group or halogen at 6 or 7 position, it will enhances the activity. Again, if this hydroxy group, the esterification, if we are doing this hydroxy group, it will increase the duration of activity. Or if we can remove the ketone group from C3 position, then also it, so हा ketone group जर आपण काढून टाकला तरी सुद्धा ऍक्टिव्हिटी ही एनहान्स होते. फॉर एक्झाम्पल लायनेस्टेरॉल. सो लायनेस्टेरॉल मध्ये तुम्हाला इथं डबल बॉन्ड ओ दिसणार नाही. सो हा पार्ट आपण काढून टाकलेला आहे. ओके. This is about the 19 not testosterone. So removal of ketone group from C3 position, it will also increases the activity. Okay, so this is about the SAR of progesterone. So SAR of progesterone मध्ये काय काय येणार, प्रोजेस्टेरॉनचं मेटाबॉलिझम होतं, त्यामुळे कुठले कुठले ग्रुप सबस्टिट्यूट केले पाहिजे. सेकंड वन 17 अल्फा हायड्रॉक्सी प्रोजेस्टेरॉनचं स्ट्रक्चर, त्याचा SAR. थर्ड वन रेटो प्रोजेस्टेरॉन, त्याचं स्ट्रक्चर, त्याचा SAR. अँड देन फोर्थ वन द 19 नॉट टेस्टोस्टेरॉन, त्याचा स्ट्रक्चर आणि त्याचा SAR. हे ती सगळ्यांची SAR मिळून तुमचा प्रोजेस्टेरॉनचा SAR हा complete होतो. So in this way we have seen the SAR of progesterone. And now we are moving to the next female sex hormone, that is the hormone estrogen. Generally, the estrogen is responsible for the development of secondary sexual characters in women. Okay, so the progesterone is responsible to maintain the uterus, but the estrogen is responsible for the development of the secondary characters. Okay. So this estrogen they are generally classified into three types. First one, human estrogen and their derivatives. So the estrogen which are synthesized in our body, in the human body or the human female, they comes under the this class. So example, estrone, ethylene estradiol, estriol. So ketone group is present at 70%. So estrone, that is the one means ketone. If here alcohol is present, here is alcohol, so two alcohol, so estradiol, and here one, two, and three alcohol, so estriol. So human estrogen and its derivative. Examples: estrone, estradiol, and estriol. And second one, the stallion estrogen. So the estrogen which are generally secreted by the male horse, they are called as the stallion estrogen. For example, equilale. And third one, that is the synthetic or the non-steroidal estrogen. So diethylstilbestrone, chlorotriancine, transtilbene, dianestrol. So these are the examples which are the synthetic or you can say non-steroidal estrogen. So diethylstilbestrone. The question is asked in the exam. Give an example of estrogen which doesn't have the steroidal rate. So you can observe here these don't have the steroidal rate, but as they consist of the functions similar like the estrogen, they are classified under the estrogen derivatives, that is the synthetic or non-steroidal estrogen derivatives. Then next part, SAR. So first point of SAR is that beta 17 beta estradiol means hydroxy group at 17 position also and at 3 position also. So it becomes the 17 beta estradiol. It is the potent. But what happens due to the presence of two hydroxy groups? It is at the 17th position and at third position. They can undergo metabolism readily and rapidly. So their duration of activity decreases. So to avoid this, what the scientist has done, they have added 17 alpha alkynyl group, and when 17 alpha alkynyl group is added, it blocks the rapid metabolism of drug 17 beta estradiol, and such drugs after addition of alkynyl group they are called as ethynyl estradiol or mestradiol. So here you can observe, here they are added the ethynyl group, that is the C triple one C. So it avoids the metabolism of 17th position hydroxy group. Okay, and here OR is present. So if OR means O hydroxy group is present, it is called as ethynyl estradiol. So estradiol OH असेल तर estradiol होणार आणि ethynyl असल्यामुळे ethynyl estradiol. जर R हा CH3 असेल, so here OCH3 is present, remaining all the structures same, then the drug is called as mestranol. So drug mestranol is there for reverse syllabus. So this mestranol is the alkynyl form of the 17 beta estradiol. So this is the first point of SAR. Second one, 17 beta hydroxy group. If we are stratified, it will increases or enhances the duration of activity. So already we are told if hydroxy group is present, it can rapidly undergo the metabolism. So if we are converted them into the ester form, it will avoid the metabolism of hydroxy group. Then third one, steroid nucleus is not necessary for the activity. So compulsory question is asked on this point, that is steroid nucleus is not necessary for the estrogenic activity. Justify. So steroid nucleus, if it is not present in the some drug, then also they can show the estrogenic activity. Hence, this nucleus is not necessary for the activity. For example, diethylstilbestrol, transtilbene, such examples you can give. Then, in case of strong nucleus, some substitutions can modify the activity. So the first one, if we are introducing hydroxy group at 6, 7 and 11 position, it will reduces the activity, because if hydroxy group is added, it undergo faster metabolism. Then second part, removal of oxygen from 3 and 17 position, epimerization of configuration, it will reduces the activity. Third one, unsaturation of ring B, it will reduces the activity. So B ring मध्ये एखादा जर डबल बॉन्ड अटॅच केलं तर ऍक्टिव्हिटी रिड्यूस होते. Then expansion of ring D, it will reduces the activity. किंवा रिंग डी रिमूव्ह जरी केली तर ऍक्टिव्हिटी सेम राहते, पण एक्सपान्शन केलं रिंग तर ऍक्टिव्हिटी ही रिड्यूस होते. Okay, so according to the Schuller hypothesis, it tells that the optimum activity for the molecule can be observed if distance between the hydroxy group is 8.55 Armstrong unit. Okay, so this hydroxy group and this hydroxy group, their distance meets with the 8.55 Armstrong unit for the optimum activity. Hence, जो मगाचा question होता steroid nucleus is not necessary for the activity. Hence, for the example, diethylstilbestrol, it does not have the steroidal nucleus, but it consists of two hydroxy groups. This one and this one. The distance between these two hydroxy group is 7.8.55 astronomy, and due to that, it follows the Schuller rule, and hence it can show the activity similar like the estrogen. So if the nucleus is not present, then also the drug can show the estrogenic activity, and they can classify under the estrogenic agents. Okay, so this is about the SAR of estrogen. Okay, so these are the 5 points which comes under the SAR of estrogen. So important part is that estrogen, they are estradiol, estriol. So they consist of hydroxy group. So this hydroxy group is present, they undergo rapid metabolism. So we have to avoid this rapid metabolism. How we can avoid? First one, we can convert them into ester form, or we can attach a alkyl group at the 17 alpha position, so they will block the metabolism. Okay, so this is the important part regarding the SAR of estrogenic agents. Now we are going to the next part, that is the anti-estrogenic drugs or estrogenic antagonism. So the drug which bind to the estrogenic receptor but does not show the activity, such drugs called as the anti-estrogenic activity. That is, they showing the block the activity of estrogen, or they shows the opposite activity. So generally these anti-estrogenic drugs, they having the two functions. They can give as a fertility drug to modify the reproductive system or reproductive process. And second one, for the treatment of cancer, we can use this type of anti-estrogenic drugs. So these anti-estrogenic drugs, they are classified into two types. One is triphenyl ethyl containing drug, that is the triphenyl ethyl analog. Second one is aromatase inhibitors. So anti-estrogenic agents, they are classified into two types, that is the triphenyl ethyl analogs. Second one, aromatase inhibitor. So first part, that is the triphenyl ethyl analogs. Okay, so they consist of triphenyl. So three phenyl group is present, then ethyl group is present. So you can confirm 1, 2, 3 phenyl group. Here ethyl group is presence. It is called as triphenylethyl analogs. For example, first drug that is the clomiphene. This clomiphene having the partial agonist activity as they are the double bond, they compound having the double bond, so it can be present in the cis isomer as well as in the trans isomer. If it is present in the trans isomer, it is called as 2-clomiphene. So here you can observe this Cl is this side, this Cl is downside. If it is cis form, it is called as N-clomiphene. This N-clomiphene generally having the agonist activity to the estrogen. So this shows the estrogenic activity. But this transform, it shows the anti-estrogenic activity or it blocks the estrogenic activity. So if we give the drug clomiphene, it consists of both the agents, that is the N-clomiphene along with the zoo-clomiphene, that is the cis plus trans, both isomers. So one is the agonist, another one is the antagonist. So you can see it is the partial agonist. So they are readily absorbed from GIT and their half-life is generally 5 days. Then you can see ethyl groups are present in ethyl group, so they can undergo metabolism by demethylation or dealkylation process, as well as this phenyl group, they are the free group, so hydroxylation can be takes place at that para positions. That is the first group, that is the clomiphene, which is present in the cis as well as the trans form. Second drug, that is the tamoxifen. So it is generally useful for the treatment of breast cancer. Its metabolite, that is the N-dismethyl tamoxifen. So here also N-CH3 present, so they undergo metabolism by N-demethylation reaction to form N-dismethyl tamoxifen, which is also having the anti-estrogenic agents. As well as we can find out here these phenyl groups are free. So here at the para position, the hydroxylation can be takes place. So at this position or this position, hydrogenation can be takes place, and such drug is called as 4-hydroxy tamoxifen because hydrogenation at 4 positions. So it is called as 4-hydroxy tamoxifen. So this 4-hydroxy tamoxifen is a minor metabolite, but it is more potent as compared with the drug tamoxifen. So these are the two metabolites. N-dismethyl means this one, and 4-hydroxy, that is the hydroxylation at fourth position. So this having the, it is minor metabolite, it is the major metabolite. So this minor metabolite is more potent as compared to the tamoxifen. And this N-dismethyl tamoxifen, it is the N-demethylated metabolite, but it also shows the anti-estrogenic activity.